Hi, this is the data model, and we have several tables. We have a Fitbit steps dataset and a calendar table, and also data for palindromes and other datasets. So we are going to concentrate on only one column today. So because we just wanted to find out if there are any prime numbers in the Fitbit data. So we are going to use the functionality of Power BI, and we'll try to highlight the key math concept, which is to find the prime numbers. So that is the goal of this video. So once we understand that concept, we can easily create a report page. So we will, in the end, we'll create a report page. First, we'll see what are prime numbers. As you can see here, a prime number is a positive integer greater than 1 that can only be divided evenly by itself and the number 1. Meaning it has exactly two factors. And the common prime numbers are 2, 3, 5, 7, 11, and so on. And again, to reiterate, the definition is a prime number has only two factors, 1 and itself. So anything else is not a prime number. It's also called as a composite number. And these are natural numbers that are divisible by 1 and the number itself. So prime numbers are positive integers greater than 1 with exactly two factors. So now that we have understood that part, we are ready to go to the next step. We will try to use a DAX function called as mod. And mod function expects two parameters. One is the number and next is the divisor. It returns the remainder after number is divided by the divisor. So now in case if we want to find out a number in our data set, a particular value of total steps, then that would be the number. And the divisor, we will try to create a table and add the value so that the number will be divided by the value, whatever value we pass. So very simple thing. As you can see, the return value is a scalar value of any type. And if you scroll down, you can also see a couple of examples for mod. For example, 5, 2. 2 goes, 5 is divided by 2 times, and the remainder is 1, and so on. So we will go back to DAX query view. We will try to build the code from ground up. Remember, prime numbers also form the basis of encryption in the widely used data encryption method, RSA encryption. So let us try to use the mod function. Let us try to use 5 and 2. 5 is the number to check and 2 is the divisor. As expected, the remainder is 1. So that is the result page. So this is the column which we are interested in today's video. We will try to check if there are any prime numbers in our total steps column. So let us try to scroll down and see these are the various numbers. Again, briefly, this is the data model we have already seen. So here are the steps. First, we will create a variable for the number to be checked. That is, in our case, it is total steps. And next, we will try to create a table by using the generate series function. And we will then use a filter over this table. In the filter expression, we will try to use the mod. And we'll try to get our filters, filter rows. And also, once we have that, we will wrap everything around count rows function. And we will get the count rows. And finally, in the return statement, we'll try to modify the condition if, as we have already learned, if the prime number is factors are 2, then that is a prime number. Like shown here, we have created a table, and in the return, we will try to see the table in the results area. So once we run that, we should be able to get the results. But in the case, we will try to check number to check should be 10. So we will get a table with 10 rows. As you can see here, 1 through 10, those are the rows. So the idea is, like I said, we want to create a measure so that we can calculate, we can find if there is a prime number in our data set. So we will next try to wrap this up in a filter function. And in the filter expression, we will try to use the modulus. And number to check is the first parameter and the value is the second parameter. Once we run this, we see that the rows are reduced, right? So we have only 6 rows as shown here. So we will try to understand why it is the case, and we will also see if we can try to know more about the filter function, how it operates, so that once we understand the logic, it should be easy for us to tweak our code and try to find the prime numbers. As shown here, those are the rows 3, 4, 5, 7, and 8 are the only rows which are spitted out. As you can see, this is a filter function, and filter function is a DAX function, and usually it is applied in calculated column or calculated table, but also sometimes we can use it directly, and it returns a table that represents a subset of our whatever table or expression which we give, right? So it expects two parameters. First one is a table, and the second one is a filter expression. So if we scroll down, we can also see those things here, like shown in the definition. We have a table. We have already passed the generate series 1 through 10. That is our table. And also in the filter expression, we will we will use the modulus function. We will try to check the number, as the number to check will be the first parameter, and the value will be the divisor. So that way we have that. And we have to keep in mind that filter expression, here, as you can see, it's highlighted, a Boolean expression that is being evaluated for each and every row. So that means if amount is greater than 0, or if the region is equal to France, only those rows are returned. That means the true values are written. So as shown here, as you can see here, we have the table here, and every row will that expression will be evaluated, like shown here: 10 over 1, 10 2, 10 3, 10 4, 10 10, so on. And when it is evenly divided, you get output as 0. If it is there is a remainder, you get all those remainders. Remainder 1 2 4 3 2 1, those are the remainders, and only those rows which are true are being shown once we run the code, right? That is exactly what we have seen. So that means those rows are shown here: 3 4 6 7 8 and 9. So as expected, that means filter function is evaluating the Boolean expression, whether that condition is matching. Only those true values are being shown here. So in mathematics, we know that 0 represent false and 1 to represent true. It is also the same case in computers science too. So here we can change the filter expression, and we want to grab only the rows where the remainder was equal to 0. That means we want to grab those other rows 1 2 5 and 10 as shown here. Now that we have done that, all we need to do is next wrap this around a count rows function. That way we get, for example, if we run this particular code, we should get 4 because we have those 4 rows, right? So the count rows will spit out that value. We will try to change the name here to mod result, and in the return we will say mod result, and also add the table constructor, because DAX query view needs a table. The result will be a table, so we will wrap this around the curly braces. Once we have that and run, as expected, those are the things, right? 4 is the answer. And to reiterate, we know that prime number has exactly two factors, that is 1 and the number itself. So we can easily kind of tweak the in the return statement. If we say that, hey, if the count row is equal to 2, then that is a prime, right? So that way we get the prime. So it's a very simple thing now. So we will try to use the switch statement here, and let me type in switch and true. And like I said, we can tweak this particular code and say that, hey, if mod result equal to 2, that is a prime. If it is not, then it is not a prime. So as we already see that prime numbers have exactly two factors, 1 and the number itself. That's why in the switch statement we can find a prime number whenever the count rows is equal to 2. If it is greater than 2, that means it's not a prime number. Very simple. We have already seen when we ran the code for the number to check 10, we got 4. So obviously that is not a prime number. We will try to add the parenthesis here and run the code again. And as expected, it says it's not a prime number. So 10 is not a prime number, we know that. And if we check, for example, 3, we know that it's a prime number, which is shown below. 1 and the number itself, because we are trying to check for number 2. So we can see that 1 and 2. And it has two factors. the one and also the number itself. If we change the number, we can keep trying and we can try to see all the numbers in our table. So for example, 3, it shows the same thing. So it is a prime number. We know that 2, 3, 5, 7, and 11 are the numbers, prime numbers. So we can see, and if we change it to 7, it is a prime number. So there are two count rows is spitting out two things. So we have two rows, and if we pick up say random number, say 7213, it is also prime number. So let us try to try to add more things here and check for other numbers too. I think so far so good. And it's a good idea to make sure that you run as many numbers as possible, number to check, so that we will try to make sure that our code is working properly. Another way we can do is we can go online and also enter this number and see if it is a prime number or not. This is a pretty good tool here, Calculator Soup, where you can just enter the number. It says it's a prime number. It is saying that 1 and 7213 are the only factors for this number. So that's great. Let us try to check all our numbers because we have a table 1 through 10. So we're checking all those numbers. And I think our code seems to be good. So, but we have to understand this is not efficient method because in our case our maximum number to check is about 28,000 in our data set, but in case in real world there could be millions, the number could be in millions or billions. So it's not a good idea because it has to build a table from 1 through that number. So it is a heavy computer resource code. So we can tweak the code and try to wrap a square root around number to check in the generate series. And that way we have a much more efficient code. And also in the return statement, we have to make the change here because as we know, we need to find only one factor because as we remember from prime definition, 1 and the number itself, right? It has only two factors. It is divided by 1 and the number itself. And in square root, we know that any number is way lower than the square root of the number. So the square root of any number is lower than the number itself. So now that we are ready, we can just make changes here. We can copy this code and create a measure named is prime. I've already done that. I've created a report page. Let us try to go to the report page. It's a very simple report page. On the top, you have a slicer and slicer, as you can see, it's coming from the calendar table. And also you have two table visuals on the bottom and also several new card visuals in the middle. So let us try to look at that. And this is the table which we have created previously and in the last video. And as you can see, we have several new measures too here. We have created what are number of primes and non-prime numbers. It's a pretty simple measure we can create by using new code here. Let us try to look at first. Let us try to look at is prime measure what we have created. We want to make sure that is correct in syntax, and it's exactly what we have done in the DAX query view. So this looks good, and I have not made any changes. So this is exactly what we have done in the DAX query view. And also, like I said, we have created two new measures. Number of prime numbers is equal to count rows and filter. And if filter condition is prime equal to that prime number, it's a prime, then it is a prime number. If not, this is a very simple code to create these two measures. And I've also gone ahead and created a conditional format measure too. You can pause the video and look at these measures. It's pretty simple measures. So just wanted some kind of color coding in the table. So whenever it's a prime number, the color is yellow in the background. You can make the changes here like as shown here. You can make sure that the measure is created and use that option so that whenever user selects any month, if there are any prime numbers, the background will be that yellow color. And as and when the user makes selections, the numbers change. So this is again another way of looking at our data. And also we have understood a new math concept, how to find prime numbers. And we can use Python too and try to expand this particular topic and try to create another, maybe we can find out more about prime numbers in a different way also. But I think I thought this way we will try to understand a new concept and also use Power BI. Thanks so much for watching. See you in the next video.